In this lesson, we're going to be talking about absolute value. Absolute value is a number's distance from zero. And what's very unique about a distance is that a distance is always positive. The symbol that we're going to use to represent absolute value looks like this. So anytime that you see a number that's inside these two double bars, that means that you're looking for the absolute value of that given number. For example, let's take a look at the first one below. Notice we have a number line, and we have two dots with a line on that number line. So the question being asked here is, what is the distance that this number is away from zero? So you can see that I have 0 indicated on my number line, and then it'll go all the way up to the number 4. So we're trying to figure out what is this distance between 0 and 4. And you're probably thinking, well, 4 units, and you're exactly right. The absolute value of 4 is 4. Now, I'm going to kind of change things up on you on the next example. Look at this next one. Off to the right here, you see that I have the absolute value of -3. So you can see on my number line that I'm beginning at 0 and I'm going all the way down to -3. And I want to know, what is the distance between 0 and -3? Well, you might think, well, -3, but think again, because distances cannot be negative. The distance between 0 and -3 is 3. So that gives you a real nice example of how the absolute value of a negative number will always give you a positive answer. Let's try number 3 now. It's a little bit trickier. This one wants us to figure out, well, what's the number that I'm going to put inside the absolute value bar? So let's look at the graph. I begin at 0 and I'm going to go all the way up to 2. So I want to know the distance between 0 and 2. And another way to say that is, what is the absolute value of 2? So the distance there is going to be 2 or 2 spaces. Notice how a positive absolute value, like this one, can also yield you a positive answer. In the last example, you can see here that I'm looking for the number that I'm going to put inside those absolute value bars, and I'm looking for a number between 0 and -4. That's the distance that I'm looking for, and you can go ahead and even count those. You can see that the distance is going to be 4 spaces, but the question is, what is the absolute value of -4? Which of course will give you an answer of 4. Notice that all 4 of my answers are positive numbers. Absolute value will always be positive. All right, let's go ahead and answer some questions. It says, determine the absolute values below. So let's go ahead and figure out the absolute value of 8. Oh, and by the way, this is a great time to pause the video and try these on your own, and then go ahead and check the answers with me. The absolute value of 8 is basically asking us, well, how many spaces away is 8 away from 0? And we know that it's going to be 8 spaces, also a positive number. Now this next question, you can see that it looks a little bit different than the first example because the blank, the question is on the left-hand side, where what the given information is on the right-hand side. Just because they flip the problem over doesn't mean that it's any different than the first one. So this is really asking us, what is the absolute value of -7? And we know that this is really asking us, what's the distance between 0 and -7, which will give us 7. Notice another positive answer. Okay, the absolute value of 1/2. This time I have a rational number inside the absolute value symbol. That is perfectly fine. Remember, a rational number is still a real number and can still be applied with this concept. So therefore, the absolute value of 1/2 is asking us, how far is 1/2 away from 0? And we would say that it's a distance of 1/2. The next example is a decimal. Remember, decimals, terminating decimals like this example, is also a rational number and can be written in this form with an absolute value as well. So the absolute value of 5.6 is just going to be 5.6, or 5 6/10. The next example is, it's asking us to figure out what's the absolute value of -1/3. And that's going to give us 1/3. Now, this last one is very tricky. Every once in a while, something like this will pop up. Now, let's go ahead and talk about this. This is saying negative absolute value of 9. So the new piece is this little negative out front. If we were to figure this out regularly, we would say that the absolute value of 9, just that without the negative, is 9. When you have a negative that is outside of the absolute value bars, what you do is you just apply it at the very end. So this answer would be negative 9. Now, I understand that in the last slide, I said that all absolute values are negative or are positive, which they are. This right here is not part of the absolute value. This is outside, and the operation that's actually happening here is multiplication. So we found that the absolute value is 9, and really what we're doing is we're multiplying it by negative 1. Okay, I know that was a tricky one, but that's okay. It's good to learn that. All right, go ahead and pause the video and try this next question on your own. Select the true statements below. So we just want to figure out which ones of these are true statements. So I'm going to go ahead through these. I can see that number 1 is not true. And the reason is you cannot have an absolute value that is going to be equal to a negative number. So I'm going to go ahead and cross that out. The next example, you can see that the number inside the absolute value bars is negative, and you can see that I have the same number outside that's positive. That makes that an absolute value. The absolute value of 100 is equal to 100. Now, even though the number 100 inside the bars is positive, the distance is still 100 spaces. Therefore, this is a true statement. Okay. Negative 3/10. That's what this number inside the bars states. Well, the absolute value of negative 3/10 is going to give us 3/10. Now notice this one is just written differently. One is written as a decimal and the other is written as a fraction, but they are equivalent in a true statement. The next example, the absolute value of negative 2.23 is equal to the absolute value of 2.23. Now, this one is kind of confusing because we have absolute value bars on both sides, which is technically, if you think about it, the absolute value of negative 2.23, wouldn't that give us 2.23? And then I'm going to set that equal to the other side. The absolute value of 2.23 is actually 2.23. So this is a true statement, written very oddly. All right, the next one, you can see that this is not a true statement because 17 the absolute value of 17 should not yield us a negative number or negative answer. The next example, you can see this is a true statement because the absolute value of negative 23 is equal to a positive 23. The next one, 2/10. 2/10. Another way to write this number is going to be 0.2, which you can see here is a true statement. The absolute value of 12 is equal to the absolute value of negative 12. You can see that if I were to simplify these down, it would actually simplify to 12 equals 12, which is a true statement. The absolute value of negative 5 is equal to 5. Well, that is a true statement as well because it yields a positive answer. The absolute value of 1/2 is equal to negative 1/2. Well, this is not true because whatever's inside the absolute value bars cannot yield a negative answer. So this is going to be false. And then the last one, see we have a decimal. So that number inside, you can see that it's outside of the bars and it's positive, making it a true statement. All right, I have 2 more examples here for you talking about absolute value. Which of the following represents the distance between points X and Y on a number line? And this is a multiple choice question. Now, here's the way that I like to attack this type of problem. The first thing I want to do is figure out the distance between X and Y. So I'm truly just going to count the spaces. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 spaces. So I know that the absolute value of the answer that I'm looking for has to be 9 spaces. And it has to be a positive 9 because distances are always positive. So now let's go down to my answer choices and try to figure out which ones of these expressions here will equal to 9. So this first one, it says the absolute value of -7 plus 2. Well, another way to say that, if I were to do -7 plus 2, that would give me -5. So the absolute value of -5, we know is 5. But we also know that that's not 9. So A is incorrect. B, absolute value of 2 minus 7. That's going to give me the absolute value of -5, which is going to be 5, which again is not 9 spaces. So we're going to go ahead and cancel that out. -7 minus 2. Well, the absolute value of -7 minus 2 is the absolute value of -9, which we know will equal 9. And you can see that this matches up to our answer above of 9 spaces. So before I go ahead and circle that answer, let's go ahead and just check the last one. 2 plus -7. Well, that's going to be the absolute value of -5 again, which will give us 5, which again is not correct. So therefore, C is our answer for this question. Here's another example. Let's first go ahead and look at the two x and y and find the distance between the two numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm looking for which one of these expressions yields positive 12, because that's the absolute value between x and y. So the first one, A, 3 plus -9, that's going to give me the absolute value of -6, which is equal to 6, which is not 12, so let's go ahead and cancel that out. 3 minus 9 is the absolute value of -6 again, which is 6, and that's not correct. -9 plus 3, that's going to give us -6 again, which is absolute value 6, which is not correct. And then -9 minus 3, that's going to give us the absolute value of -12, which is going to give us a positive 12 as my answer, making D the same number of spaces as the given problem on the number line. All right, that brings us to the end of our lesson on absolute value.